Okay, hello everybody. Today I'm presenting the Afterlife, or languages after JavaScript. So to start out, I'm Jennifer Wong, and this is my cat Fry. He's featured later in the presentation as well. I currently work at Eventbrite as a software engineer, and what you see on the screen is a huge cake with the name Eventbrite as a celebration of our 10th anniversary. Some people know me as the creator of Human Wasteland, also known as the poop map of San Francisco. And if you don't know what that is, feel free to ask me afterwards. Or you may know me as the creator of Developers, which is a dedication to Mr. Steve Ballmer. So way back before all of those projects, I actually used to work as a civil engineer. And during that time, the languages... I actually say that my first programming language is JavaScript, and that's a bit of a lie because when I was a civil engineer, I learned Fortran as well as MATLAB, and when I was doing my master's in mechanical engineering, I learned G-code and embedded C for CNC machining as well as electromechanical systems. So I didn't like any of those languages. I didn't really take to any of them, and that's why I like to say that JavaScript was my first language. Fast forward a little bit to 2010 to 2012, and I was actually working in customer support in the tech industry. And that was quite an interesting experience, and that's what led me into programming today. So just a bit later, let's talk about some current events that were going on in 2013. The first developers kit for the Oculus Rift was released. Amazon CEO Jeff Bezos announced that there would be Prime Air, or delivery by drone. Google Glass was first released in 2013. And the UK was still pretty happy about being part of the EU. And at that point, I also learned JavaScript. And I was pretty excited about it. It's like, good news me. So this is a tweet from 2013 with a screenshot of me pointing out that JavaScript was number 7 in the new programming languages to learn in 2013. So I was like, yay, I chose correctly. And I started to use JavaScript. So here I'm tweeting, yay, my first JavaScript. And here we can actually take a look at the first JavaScript I ever did. So here's what my website used to look like in 2013, and this is the first pieces of JavaScript I wrote, which is just this silly navigation. And you can tell it's vanilla JavaScript because it's just jumping around all over the page. So that's a peek into my history in JavaScript. All right, so let's fast forward a little bit to 2016. We now have access to a 3D experience at $15 with Google Cardboard. 7-Eleven paired up with a company called Flirty to actually make 77 deliveries by drone prior to Amazon and Google doing so. Google Glass doesn't really exist anymore. And the UK is not so happy about being part of the EU. But I'm one to talk. So speaking of trash fires, JavaScript's been a little bit crazy these days. And so I decided to learn Python while I was working at Eventbrite. And I was getting a little bit confused by it. So here you see me tweeting that I'm concurrently writing JavaScript and Python files to demonstrate the differences between the two languages to my coworkers and all of the weirdnesses between the two. So that's kind of the beginning of this talk, is I was presenting to my coworkers and letting them know what parts of Python were confusing to me coming from the background of JavaScript. So if you could all think back to a day when you had first learned a program, you knew one language, you thought that was the end-all be-all, that was the one language to rule them all, and it was the greatest. Now think back to when you learned your second language, and for those of you who have only learned one, don't worry, your time will come. But do you remember those times when you would be writing code and you would confuse your syntax and you just start typing things And things would get mixed up, and you'd run your code. The compilation would be a little strange, and you'd be like, wait, why is that not working? And then you realize that you've written it in the other syntax. So that's kind of what this talk is about. It's about trying to write in a new language after just working solely in one for such a long time. So basically, I'm trading in my curly braces and semicolons of JavaScript, and I'm getting a bit of rules via Python. And a quick history on both Python and JavaScript. So Python, we see here, is a high-level, dynamic, interpreted programming language. It emphasizes code readability, and its syntax expresses concepts in fewer lines of code than originally possible in languages such as C++ and Java. JavaScript is, again, a high-level, dynamic, interpreted, and untyped programming language. So actually, the two, if you look, they sound about the same. They're high-level, dynamic, and interpreted. It's just that JavaScript is untyped, specifically. So just to compare the two, I have this table, and you'll see that both Python and JavaScript have the paradigms of being functional, imperative, and object-oriented, although with JavaScript, it's prototype-based. Python was created in 1991, JavaScript in 1995, and you'll see that they're both inspired or influenced by C, Java, and Perl. But you also see that JavaScript was influenced by Python. And so I was like, oh, does that mean that they're pretty similar? And they kind of are, but when you're learning them for the first time, they're really not. So let's start a little bit small. Some of the first things that I learned in Python were comments. So I can't tell you the number of times that I've made mistakes with comment syntax. Partially because with CSS, common syntax is almost exactly the same as JavaScript with the multi-line slash and star. Actually, later on in this talk, it's funny, I just made corrections to some of my code pieces. I had double slashes in some of my Python code later on, and so you can see I'm still getting confused, even though it seems very simple. And really, when I look at the comment syntax, it kind of just looks like a face with spiky hair to me. Okay, next is white space. So when I was learning JavaScript and I knew JavaScript, white space didn't really matter. JavaScript was like, it's not a big deal, don't worry about it. And Python is like, no, white space totally matters. It's really important. And then that just made me like super confused. So I tweet a lot, as you guys can tell. And so you see here I'm saying, I'm doing Python, and I'm all like, what? And you'll see that I have an indentation error, and Python expected an indented block. So even when I was first learning Python, you would think that white space wouldn't be such a big deal. But in Python, it's really important to have all of your blocks indented in that specific way. Okay, next are primitives. So again, primitives seem pretty straightforward in JavaScript and Python. So first you'll see the booleans, which are true and false, although in Python, true and false are capitalized. If you want to refer to nothing in JavaScript, it's null, and in Python, it's none. What was really confusing to me is I didn't know that in JavaScript, the idea of something being undefined or having an empty value was so special. It seemed completely normal to me. So when I was learning Python, I was very confused to learn that that was not something that was possible. The other thing is, with JavaScript and Python, I didn't understand that with Python, there are all types of numbers, whereas in JavaScript, there's just one type of number. It's pretty straightforward. And then as well, with sequences, I didn't understand that there were different types of sequences in Python, because in JavaScript, there's really just arrays, although with the addition of ES6, we now have tuples as well, or tuples. I'm not sure how it's pronounced, actually. And then lastly, with a key value store, in JavaScript we call them objects, but in Python we call them dictionaries, which can be a little confusing as well. So with primitives in general, I learned that capitalization really matters. I don't even really want to talk about the number of times that I had compilation errors just because I didn't capitalize true or false in Python. So when I was learning about these primitives, I was like, what are all of these things? Because with JavaScript, we just have a normal number. And then in Python, we have ints, we have floats, we have longs, and we even have complex numbers with real and imaginary parts, which is pretty crazy. And again, with sequences, we have lists, and then we have tuples or tuples, and then we have byte arrays, we have buffers, which are now called memory views in Python 3, and then we also have X ranges. So at first I was really confused by why would Python have all these different types? Why can't we just be like JavaScript and be a little bit more straightforward and just have one type of number or one type of sequence? And then my coworker Alice helped me realize an idea, which is that there are trade-offs with different languages. So with JavaScript, you could get faster development, and you may have more runtime errors. But with Python and specific types of primitives, you may have slower development, but you'll most likely have fewer runtime errors. And so it's kind of a take your pick regarding languages. Okay, next step is concatenation. So concatenation is pretty easy with both JavaScript and with Python. You essentially use a plus sign and you can add some strings together. One thing I didn't understand about JavaScript is that type coercion is something special, and it's not something you can do in Python. So here you'll see I have a coerced number, and I basically, by concatenating it, coerce it into a string in JavaScript. And with Python, you just can't do that. It's not possible. So when I was presenting this to my coworkers, my coworker Emma literally made this face to me like, whoa, what do you mean you can do type coercion? She was not happy about that at all. Okay, next step is functions. So I'm going to go a little bit deep on different types of functions, but first I'll start with functions and conditionals. So here you'll see a function called Dr. Seuss, which basically tells you if things are crazy or if they're boring based on the cat in the hat, thing 1 and thing 2 being there. So some of the first things that I noticed about Python is that it's pretty similar syntax-wise. You start with an if, and then instead of saying else if, as in JavaScript, you say elif, and then you say else, just as in JavaScript. So the only thing that's different for me is curly braces versus colons. And I feel like if you look at the two, just as code, without even really reading it, Python's definitely looks a lot better. And when I was first learning Python, I was like, nah, JavaScript's better. I miss those curly braces. But now I'm kind of coming around to the fact that, yeah, Python, okay, it does look a lot cleaner. And here's another one of the examples where I actually had true as lowercase. So I actually had to come back through and make sure I had all capitalized trues in Python. So another thing with JavaScript is I didn't understand that there was a difference between functions and methods. So Python helped me realize that. So MDM says with functions versus methods in JavaScript that the global function object has no methods or properties of its own. However, it does inherit some methods and properties through the prototype chain from function.prototype. So that means that essentially every function in JavaScript that is declared is inheriting from function.prototype. And that's where methods come from. So an example of the methods that you would acquire via the prototype chain are apply, bind, call, isGenerator, toSource, and toString. So for me, having learned JavaScript, I thought that essentially functions were declared or created, and that methods were inherited or built into functions, or built into the language of JavaScript. So it wasn't until learning Python that I learned that functions and methods are actually fairly different, and that in most respects they're basically the same, except for that a method is implicitly past the object on which it was called, and that a method is also able to operate on the data that is contained within the class. And then I was like, oh, is that why I didn't understand the difference between functions and methods? It's probably because there are no classes in JavaScript, although there are now in ES6, which I'll talk about in a bit. So I'll take a quick look at some silly functions and methods that I wrote in Python. First, you'll see that I have a function called fish and chips, which is essentially created and declared outside of a class, and so that's a function. And then I have a class called baking, and inside that I actually have a method called bakewelltart. So because that is actually called within baking, that's what makes it a method. And you'll see as well that if I log or print self, you'll see that I have access to the object on which it was called, which is baking. And so I was like, oh, duh. Okay, that's why I didn't understand the difference between JavaScript and Python's functions and methods. Okay, next is ternaries. So ternaries are pretty straightforward as well, but for some reason, nobody wants to agree on syntax here. So with JavaScript, you have the results of the condition at the end, which is yes, no. And at first, I kind of liked the way that was organized because you have the conditions right at the end. But then I noticed that the way Python writes things is it's written more as a sentence, so you could read it out. Like, do I like children? Yes, if they're well behaved. Otherwise, no. So it's kind of another situation of take your pick on which you prefer. Okay, so let's get a little bit bigger now. Those are all kind of like the basic underlying principles of JavaScript and Python. But now we're going to talk about prototypes. So prototypes are a little bit crazy and generally super confusing to everyone. I was going to say to anybody learning object-oriented languages, but really they're confusing to anyone. So when I hear prototypes, usually I think of basically an early sample of a product, like these rings here. It's like a prototype of a ring before they're actually put into production. There's also a video game called Prototype, and there's also a French indie band called Prototypes. So let's talk a bit about inheritance and the prototype chain. MDN says that when it comes to inheritance, JavaScript only has one construct, objects. Each object has an internal link to another object called its prototype. That prototype object has a prototype of its own, and so on until the object is reached with null as its prototype. And null, by definition, has no prototype because it's nothing, and it acts as the final link in the prototype chain. So I was reading that, and I was like, did somebody create a band called Inheritance in the prototype chain yet? So to explain that a little bit more clearly, here I have a prototype chain. So I start out with an object called B. Don't ask me about this chain or any of the properties. It's not something that I wrote. It's a little bit silly, but B essentially inherits from the bean prototype. Bean inherits from the legume prototype, and legume inherits from the object prototype, which is built into JavaScript. So you can see that there's this prototype chain here, and that B is an instance of bean, the bean prototype is an instance of legume, and the legume prototype is an instance of object. So to explain that a little bit further, basically, Python helped me understand, because it was class-based, prototypes in JavaScript. So I found JavaScript's prototypes extremely confusing prior to learning Python. So here I have a pretty long example. So I'm going to go through it step by step. But essentially, I'm creating a mammal, I'm creating a cat that inherits from mammal, and then I create a method called eat on cat, and then I instantiate a new cat called fry. So to start, I have essentially the declaration of mammal. So I start out and I say that mammals all have a neocortex. So you'll see above I have it in JavaScript. I'm creating a new function, and then in Python I'm creating it as a class. That's pretty easy. Next, I create a cat. So I create a new function, cat, in the top with JavaScript, and I give it a name, and I also give it a number of years. And then from there, I create the cat prototype, and I set it as a new mammal. So essentially, the cat prototype is inheriting from mammal. And then I set on the cat prototype a method eat. And then below that, you'll see me creating a class in Python called cat. And it's much more straightforward here. So I can just actually feed mammal directly into cat in order for cat to inherit from mammal. And then I initiate that with a name and number of years again, and then I create a method called eat. And lastly here, what I do, I feel like this is probably the closest between JavaScript and Python is mostly in the function call. So when I instantiate a new Fry cat, he is a new cat, and his name is Fry, and he's 7 years old, and then he's eating some steak. So because Fry cat is inheriting from cat, it grabs that method. And at first I found this super confusing because with JavaScript you have these words new, you have new functions, you have this new word called prototype. But once I had these mapped side by side, it was much easier for me to understand JavaScript's prototype. And for sitting through that very long example, you guys are rewarded with a photo of my cat eating some steak. Okay, scope. So scope seems like it would be pretty crazy between the two, and nobody really likes to talk about scope. But actually, with JavaScript and Python, scope is pretty straightforward. They're almost exactly the same. They both use lexical scope. The namespace in Python is specifically functions, classes, and modules, whereas in JavaScript, only functions will create scope. Although, again, with ES6, we actually have now classes and modules creating scope as well. And then with Python, you have the new identifiers of variables, functions, and classes, whereas with JavaScript, you have variables and functions, again, because there are no classes. So scope's pretty easy between Python and JavaScript. And I was like, okay, that's one down. Okay, now there's this versus self. This is a really confusing concept, again, in JavaScript. So this is from JavaScript, whereas self is from Python. So you'll see self kind of referred to quite a bit when creating classes in Python. So I was wondering, are those two things the same? They seem kind of similar. And I was like, I don't know. So I had to do a little bit of research on that. So actually with JavaScript, this is a special keyword. And in Python, self is not a special keyword. It's actually a convention. So this can refer to the global object or the containing object depending on the execution context. So this can refer to many things depending on essentially where it's declared. Whereas self in Python is just a convention. So it's the explicit first argument of a function, and it refers to that instance. So you could actually name self this in Python if you wanted to. And even MDN can kind of admits that this is quite confusing in JavaScript, because you'll see here there's a function where they say this.herp is equal to derp, and they also say this is easy to understand is equal to just kidding. This is an actual example on MDN's website. And then to top all of that off, there's also window.self, which is accessible with JavaScript. So this could be self if you're in the global scope. So you'll see here I have a function checking to see if window.self is window, if window.self is this, and if this is equal to window. And all of those are true, assuming that this function is executed in the global scope. So this versus self, is it confusing? Yes, very confusing. Okay, now we have hoisting. Hoisting is something that I didn't understand, again, that was something special in JavaScript. I thought it was something pretty straightforward, just a weird quirk in JavaScript, but my coworkers, again, were quite horrified to learn what hoisting was. So to explain hoisting, I have here essentially a variable called boba, and I first assigned that to passion green tea. So you'd assume that that would log below passion green tea. And then I have a function called my order, or Jen's order. I log boba at the beginning of that function, and one would assume it would go out to the global scope and say, oh, that must be passion green tea. So you'd assume that it would declare that, or print that. And then I create boba again inside of that function, and I assign it to mango green milk tea, and then I log it again. So you'd assume that that would log mango green milk tea. So actually, what's super confusing is that second console log inside of my function logs undefined, and the reason for that is hoisting. and because the fact that JavaScript has the idea of something being undefined. So with hoisting, you hoist the variable definition or variable declaration, var boba, above that console log. So because var boba hasn't actually been assigned anything, what gets logged is undefined. So that's super confusing. And again, that's something that is not possible and doesn't exist in Python. So here you'll see I have a function called gensorder in Python, and I print boba. And by doing so without declaring boba or assigning it, Python is like, no, that's not possible. You can't do that because there's no hoisting. Okay, next is ES6. So ECMAScript 6 is a new standard which was released in 2015 by ECMA International. Prior to that, a full version of JavaScript hadn't been released since 2009. So you could say that ES6 was upgraded, is an upgrade of JavaScript or ES5. A quick note about ECMA International versus the Python Software Foundation, which I didn't know about. So ECMA International is the group behind the standards of JavaScript. And they're actually a private nonprofit, which means that you can only join if you're part of a huge organization, and you have to pay into that private nonprofit. Whereas with the Python Software Foundation, anybody could be a member. So you could go and join today and be a member of the Python Software Foundation, which is a nonprofit. It's pretty cool. My coworker Ashwini is actually on the board, so it just goes to show that you could really be part of that if you wanted to, very easily. Whereas with ECMA International, it's much harder. So that being said, learning ES6 has been really interesting for me because Python has helped me also learn ES6. So a lot of syntax in ES6 overlaps that of Python. So I like to kind of say that they go hand in hand. So to start, block scope in ES6. So when I was first learning JavaScript, I thought that several things created scope in ES6, or excuse me, in ES5. So I thought that if statements and conditionals created scope, and then I was told that that's not true. But with ES6, it's actually now true. And so when somebody told me that block scope exists, I was like, what do you mean that exists in ES6? So with the addition of const and let in JavaScript, we now have block scope. And as an example, I have this function called simple example, in which I have a conditional if value, then I assign var value to value, and then I assign let value to value as well, but that's using let. And then when I console log both of those, I get the value because they're just declared within that scope of that block. However, outside of that conditional, if I try to print out var value, that's no problem because that's part of ES5 and there's no such thing as block scope at that point. But if I try to print let value, because of block scope, I actually get an uncaught reference error. And so that's something to keep in mind when you're creating scope now in ES6. So now I actually have to add on a couple of things to my table from earlier. So we actually have more things that create scope in JavaScript than in Python. Okay, next is template literals. So template literals are string literals that allow embedded expressions, and they were originally called template strings in prior editions of ES6. So template literals are something that actually already existed in Python and something that I had already learned. So that made it much easier for me to understand those in ES6. So see here a JavaScript template literal. So I declare both, I create exclamation, assign it to a string whoa, and then I also have a sentence. They're really similar to Python. And then when I log the template literal, which basically has some placeholders for the exclamation and the sentence, what I get is a printout of template literals : whoa. They're really similar to Python. And it's pretty great because then you don't have to use the concatenation and it's more straightforward. Just having, it's almost like Mad Libs, if you guys are familiar with Mad Libs. And then in Python, you'll see it's pretty similar as well. So using dot format in Python, I have a string, and by using dot format, those placeholders with the curly braces will just fill in with the two strings that are fed into dot format. So this will print out dot format, colon, yep, quite. And then those two side by side, you can see they're quite similar with the curly braces for the template literals. Okay, next is default parameters. So again, default parameters was something that already existed in Python, and that made it easier for me to understand in JavaScript. So here you see a default parameter. I have a function called nom, and my default parameter, food, is set to ice cream. So if I want to call nom without an argument fed into that function, it'll automatically just print out ice cream as a default parameter. So it's time to eat ice cream. And then again, with Python, it's very similar. So you can have a default parameter. Again, food is set equal to ice cream, and then we print out time to eat ice cream, even though we've called the function without any arguments. And here we go, side by side. Okay, next is rest parameters versus args in Python. So the rest parameter syntax allows us to represent an indefinite number of arguments as an array. And that's actually something that already existed in Python from its inception. So here in JavaScript, I have a function which is a joke, and I log the question, and then I just go through and I print out each of the phrases that's fed in to the rest of the function. So here I assigned the ES6 joke as, why does JavaScript single out one parameter? And then I call that joke I call the function joke with the ES6 joke, and then three other strings, which will get essentially smashed into an array at the end. So then I'll print out, why does JavaScript single out one parameter? And then it's because it doesn't really like the rest of them. So with Python, something very similar is our args here. So here I have a pirate joke, and then I can take a question, and then I take a bunch of args, which are smashed into an array. So I print the question, and then I loop through and print out the different arguments that are fed into the rest of the args, or fed into the rest of the function. So with my Python joke, it prints out, what's a pirate's favorite parameter? Args, args, args. That's my pirate joke. So it's pretty cool, very similar between Python and JavaScript. Okay, so now we come to classes. We talked about prototypes earlier in JavaScript, but now we have classes with ES6. But as it turns out, they're just syntactic sugar, so they're still based on the prototype idea or the prototype chain within JavaScript. So I like to say that classes are like Prototype 2, the new video game. So again, we see this example of mammal and cat, and then I instantiate a new fry cat. So the only differences here now is that you'll have a constructor, and you actually declare a class mammal in ES6 as well. So it's pretty similar to the way it looks in Python here. A big difference, which makes things much easier, is that you can inherit more easily. So here, cat inherits from mammal by just saying extends mammal, and that's much more similar to the way that Python inherits mammal. And again, we have a constructor, which is pretty similar to the init function in Python. So you'll see that the syntactic sugar kind of helps things overlap much better or much more easily between the two languages. And so I like to say that it's like we're breaking the prototypes and building something new that works out really well. Okay, so in conclusion of all of this and learning Python after learning JavaScript, so what I learned is that JavaScript has a bunch of weird quirks that I wasn't aware of. I just thought it was natural, and I thought, all of those things happen in all different programming languages. So I thought that and then I learned that JavaScript is like kind of actually a free-for-all. You can do a lot of different things. It's a super flexible language, and I thought that that was something that I really liked. And it can be really helpful as a beginner because you can't really make mistakes in JavaScript, or it's very hard to. But then I started to feel like, oh, maybe that's a bad thing. I'm not really sure how I feel about it anymore. And I got a little bit sad because I was like, JavaScript used to be my language to rule them all. But Python has actually really helped me appreciate all of the things that I've learned in JavaScript. And I've also learned that some rules actually can be good. And so this is how I felt after learning Python. And here's Mary Berry winking, because why not? So thanks, everybody, for coming. I hope you enjoyed it. And if you have any questions, feel free to ask.